we're talking about the difference of two squares, which is the special product. So if your beginning number of your two terms is a perfect square, and the last number is a perfect square, and you have a minus in between, then you can factor that into two binomials just like you do a trinomial, okay? So what you do is you square root the front number. So if I take the square root of a squared, that would be a. That goes in the fronts. If I take the square root of the back number, that would be b, and that would go in the back spots. And then I always have a plus and a minus, okay? So if you look at number 1, is x squared a perfect square? Yes, and how do we know if a variable with a power is a perfect square? What powers are perfect squares? Those are called evens. So even powers are perfect squares, okay? That's because to take the square root of one, you would just divide it by 2. So I have a perfect square. Is this a perfect square back here? 9's a perfect square, right? 3 times 3. And then you have a minus sign, correct? So I'm going to split that into two binomials. All right? Since I'm doing this, I'm going to have a plus and a minus. And then I'm going to square root the front. So what's the square root of x squared? And what's the square root of 9? And then I'm done. Okay? And so that would be done. This is why this works. So your front number is always your front number times your front number, right? And your back number is always the back times the back. And then that term that's usually in the middle, that is the outside, the inside, multiplied and added together, which makes 0, right? Because they're opposite signs, and that's why you don't have the middle. So that's why it only works if there's a minus there, okay? So look at number 2. Do you have two perfect squares? And you got to make sure you check the number and the variable here. So 4x squared, is that perfect? Okay, what about 1? It's the perfect everything, right? 1 times 1 is 1, 1 times 1 times 1 is 1, 1 times 1 times 1 times 1 is 1. All right, so I'm going to go ahead and factor this. What kind of signs will this have? Plus and a minus. What's the square root of your 4x squared? 2x. That goes in the front. And then what's the square root of 1? And then you're done. All right. Do you have two perfect squares with a minus sign? So we can split that into two binomials. The signs are positive and negative. The square root of x squared is, and the square root of 25 is, and we're done. Perfect squares? Yes. Minus sign? Yes. Split it into two. What are your signs? Plus and a minus. The square root of 100? That goes in the front. The square root of m squared is m. That goes in the back. And you're done. All right. So do you have two perfect squares with a minus sign? Ooh, okay. So I can't split that into two, right? Because I have a plus sign. And also, do you have any common factors? No. So this is not factorable. Can't do anything with it. You have to have the minus sign. So not factorable. Okay, number 6. Do you have two perfect squares and a minus sign? Yes. All right, so we split that into two signs. The square root of x to the 6th, x to the 3rd, and the square root of 81. And every now and then, one of these will also be the difference of two squares. Like this one almost is, but 3, that's not a perfect square, right? But if it was, then you could do it again, right? And end up with 3, if it happens that way. Okay, So now let's talk about perfect square trinomials. Okay, there's a few more things to check other than just perfect squares in front and back and a minus in the middle. Okay, in this one you have to make sure that this number in front is a perfect square and this number in back is a perfect square, and that there is a plus at the back. And then the middle is 2 times the square root of the front number times the square root of the back number. And what happens is that when you factor those, you get 2 of the same. So we had a worksheet earlier this year where we had like r plus 9 and r plus 9 or something like that, and it was r plus 9 squared. That means that that was a perfect square trinomial. You get 2 of exactly the same thing. Okay? Now, most of the time, though, when you see this trinomial, you're just going to factor it like normal, right? Which is going to be faster most of the time. But today we're going to practice doing it the special way, because some of them, it's actually easier to do it that way than it is to do it the normal way, if that kind of makes sense. All right, so the very first thing we're going to do is we're going to check to make sure that this is a perfect square trinomial. So do you have a perfect square in the front? Do you have a perfect square at the back? And do you have a plus sign? Now you have to make sure that your middle works out. So you would take 2 times the square root of the front, which is x, times the square root of this back number, which is 4. Does that make 8x? Yes. So this is a perfect square trinomial, which means it's going to factor into 2 of the same exact thing. So if I were going to factor this normal, I would look back here in this plus sign. It always has a plus back here, right? That's one of my stipulations. So it's always going to be 2 of whatever sign you have in the front. So you can just look at the front sign. All right? And then you're going to take the square root of the front. What's the square root of x squared? X, which didn't we already talk about that when we wrote this down? And then the square root of your back number is 4, and you're done. Now, if I factored this like normal, I would say what multiplies to make 16 and adds to make 8, which would be 4 and 4, right? And then we can write this as x plus 4 to the second power. This is just part of the checking. It's always a 2. Because this is why. The middle is 2 of the 4x, right? The middle is always the outside multiplied together and the inside multiplied together, added together. And since it's perfect, that's a 4x and that's a 4x. So it should always be 2 of the same thing, right? That's why it's always a 2 when you're checking it. Okay. So let's check number 8. I started out with easy ones. So is this a perfect square? Okay. Are you a perfect square at the back? And do you have the plus sign? So now you check your middle, which should be 2 times the square root of the front, which is m, times the square root of the back, which is 1. Does that make the middle? Okay, so I'm going to factor into 2 of the same. What will your signs be? Good. And then you take the square root of the front, which is m, that goes in the front, and the square root of the back, which is 1. So I end up with 2 of the m minus 1, so m minus 1 squared. Now technically, if you already know that you're going to get 2 of the same, couldn't you skip this and just jump down to this? Okay, which is totally doable. Okay, so now we're going to talk about the whole purpose of doing the factoring, like what does it even mean, right? And so we get more into that later, but today we're going to kind of scratch the surface with these perfect ones, and I'm going to give you more information than what you actually need, okay? So I can't factor this yet because I've got a bunch of fractions, and that's posing a problem, right? I don't like that I have these numbers in the bottom, okay? So you need to get rid of them. So you need to think about your least common multiple. That's the smallest number that both of them will go into. So not the smallest, not the biggest number that goes into each of those, but the smallest number that both of those go into. So in other words, I can't pick anything smaller than 9 because 9 is not going to go into 8, 7, 6, 5, 4, 3, 2, right? So what would be the number that both 3 and 9 can go into? 9, not 3, because 9 can't go into 3, right? 9 has to go into the number as well. All right, so 9 is the smallest number that both of these go into. 3 will go into 9, right? And 9 will go into 9. So I'm going to take and multiply every single term I have by 9. So I'm going to take 9 times the x squared. And then I'm going to take 9 times the 2/3 x. And then I'm going to take 9 times the 1/9. And then this time, now we have an equal sign. That's different. So I'm going to take 9 times the 0, even though it's not going to do anything, just to keep things uniform. So you're just going to take that number that both the bottoms go into and multiply by it. Then I'm just going to simplify. So 9 times x squared is just 9x squared. And then you can plug 9 times 2/3 in your calculator if you want to, but 3 will go into 9 3 times, and 3 times 2 is 6. And then on this one, the 9s will cancel, so I just end up with a 1, and that's equal to 0. So our goal here is to solve for x, right? But we can't solve for x when we have an x squared and an x. You have to get it down to something that you can, set equal to 0. So you could do the illegal move here, but that's not what we're practicing, right? We're practicing the perfect square stuff. So we're going to check to see if this is a perfect square. So is this a perfect square in front? Do you have a perfect square in the back? And 2 times the square root of 9x squared is 3x times the square root of 1 is, and does that multiply to make the middle? Yes. So I know I'm going to get 2 of the same. So I'm just going to go ahead and put something squared, right? What was the sign going to be in my 2 sets? A plus. The square root of the 9x squared is 3x, and the square root of 1 is 1. All right? Now, my job is to solve for x. See how I don't have an x squared and an x anymore? So how do I solve for x? No. I have to get into the parenthesis first, and what's in my way? The squared. So I need to square root to get rid of that. So 3x plus 1 is equal to, normally we would say plus or minus 0, but 0 is just 0, right? And now what? Subtract the 1. So 3x is equal to negative 1. And then we divide by 3. So I get x is equal to negative 1/3. Now what you're going to learn later is that if your biggest power is a 2, then that means you have 2 answers. Okay? And I'm only showing 1. Here's the thing. I could write this like we've been writing it, right? 3x plus 1 times 3x plus 1. And each of those represents an answer. I have 2 sets, right? So here's the thing. If I've got 2 times a number is equal to 0, tell me what the number is. 0, right? So that tells me that this has to be equal to 0, or this can be equal to 0 to make this whole thing equal to 0, right? This answer counts for 2 answers. We call that a multiplicity of 2. And on a graph, I'm going to show you what that means. All right, so if you look at this graph, see how it's curving on the x-axis right there? And guess what that number is? It's negative 1/3. Okay? All these answers that you get represent your x-intercepts, where you cross the x-axis. So if I get 2 of the same, then that means that it's going to curve on the x-axis at that number. And if I actually go to my table and I plug in negative 1/3, I get 0. That's because I'm sitting on the x-axis. So anytime you get 2 of the same number, that means that it's curving on the x-axis. Otherwise, it's just crossing. So like if I got 3 and negative 4, it's crossing at those points. Okay? So we would say that that's a multiplicity of 2, but we're not going to worry about that today. We'll just count that as our answer. All right, so number 10. We don't have anything funky going on, right? And most of the time we would just go ahead and factor that like we normally do, but we're practicing today our factor thing, perfect squares. So do we have a perfect square up front and at the back and a plus sign? And 2 times square root of the front, which is a, times the square root of the back, which is 3. Does that make the middle? Yes. So instead of doing the squared thing, I'm actually going to separate it into 2. What will my signs be? Pluses. The square root of a squared is a, and the square root of 9 is 3. I like to do it this way because then I can make sure that I definitely know I have 2 answers, right, that are the same. But do I need to set them both equal to 0? No. I can just do 1 because they're both the same. So if I set one of those equal to 0, then my answer is -3. So what does that mean on a graph? What's happening on my graph? It's going to curve on the x-axis at -3, right? So it's counting for 2 answers. Okay? Number 11. I got the funky stuff going on again, right? So I'm going to have to get that off the bottom. So I need the smallest number that 3 and 36 will go into. 36. So I'm going to multiply everything by 36. So I've got 36 times the x squared, and then I've got a minus sign. 36 times 7/3 x plus 36 times 49 over 36 equal to 36 times 0. And by the way, this will come in handy later when we have like x's in the bottom, because then we're going to have to do that same exact thing. All right, so I have 36x squared. 3 will go into 36 12 times, and -12 times 7 is -84. And then over here, 36 cancels, right? So I have 49 equals 0. So this is one of those where it's way faster for you to do your perfect square trinomial shortcut, right? Because if you have to take 36 times 49, that's going to give a huge number for you to do your illegal move with, right? It's going to take you a long time to figure that out. Whereas if you just say, okay, is that a perfect square? Yes. Is 49 a perfect square? Yes. Is there a plus sign at the back? Yes. Is my middle right? So 2 times the square root of your top front, which is 6x, times the square root of 49, which is 7. Does that equal 84? Yes. So then I know that I'm going to get 2 of the same. What are the signs going to be? Minus, right? The front will be 6x, and the back will be 7. That's a lot faster than it was going to be the other way, right? So I'm going to take both of these and set them equal to 0. Well, I don't need to do both, right? They're the same. So I'm going to add the 7. And then divide by 6. So x is 7 over 6. And how many answers does that actually count for? 2. And what's happening on my graph? I am curving on 7/6, which is like 1 and 1/6, right? Okay. Number 12 is different. You don't have 3 terms, right? So when you don't have 3 terms, you should be looking for what? A minus sign with 2 perfect squares, right? Do we have that? So that's the difference of 2 squares, right? All right, so I have a minus sign, which means I'm going to have plus and minus, right? What's going to go in the front of these? And what's going to go at the back? So I have two separate answers now, correct? So what am I going to do with these parentheses? Got to do both of them, right? N plus 9 equals 0, and N minus 9 equals 0. In other words, I'm going to get the same answer, but they're going to be separate, different signs, right? So this one I get negative 9, and then this one I get positive 9. So what does that mean about my graph? What's happening on this one? So it's curving somewhere other than on the x-axis. So in other words, it's just crossing the x-axis at negative 9 and positive 9, right? Just cutting straight through. All right. So number 13. We're back to having a trinomial, right? Yes? So we're going to check to see if it's perfect. Do you have a perfect square in front? Perfect square in the back? Plus sign? And then 2 times the square root of s squared, that'd be s, times the square root of 10 is 10. Does that make the 20s? Yes. So I get 2 of the same. What are your signs? Good. What goes in front? And what goes in back? What's your answer going to be? Yes. S equals negative 10, right? Because if I set it equal to 0, all I'm going to do is subtract 10. Now, how many answers does that count for? 2. And what's happening on my graph? It's curving on the x-axis at negative 10. All right. So on number 14, what do you think we're going to have to do to this before we can do anything? We need to get everything on one side. Now, which side would be the smartest side to move to? So you want to move this way? If I move this way, the y is going to end up being negative. Do you want a negative y squared? No, so it would be better to move these two over here. So I'm going to subtract the y and add the 36. So that would give me y squared minus 12y plus 36 equals 0. You always want that 0, right? So you'll want to move to whatever side makes it easiest for you, right? You don't want a negative y squared. That causes problems, okay? So I'm going to check to see if this is perfect. Is y squared a perfect square? Is 36 a perfect square? Do you have a plus sign? And then 2 times square root of the front times square root of the back. Does that make the middle? Okay? So I'm going to have 2 of the same. What kind of signs? Okay, what goes in front? And what goes in the back? Good. And your answer will be? Okay, you're really just doing the opposite of this, right? Okay, but if you set it equal to 0, you would get positive 6, correct? I mean, if you're thinking about this mentally, what minus 6 would give you 0? That would be 6, right? I mean, it's easy to think about. That counts for 2, correct? And that means we're curving on the x-axis at 6. Okay, what about 15? What should we do? Okay, so I need to move my 49. So I get 4x squared minus 49 equals 0. I don't have a trinomial, so I should be looking at 2 perfect squares and a minus. And if I don't have 2 perfect squares and a minus, then maybe I need to factor a common factor out first, right? That could be a possibility. So, do I have 2 perfect squares and a minus? So I have 2 binomials. What are the signs? Plus and minus. What's going to go in my front? 2x, and what's going to go in my back? And then what do I do with these parentheses? Set them equal to 0. Okay, so if I'm going to solve for x, I need to subtract 7 and then divide by 2. And then this one's going to be exactly the same, only it will be positive, right? Because instead of subtracting 7, I will be adding 7. Okay, go ahead and put equals 0 at the back of these because I failed to do that. All right, so number 16. What should we be looking for here? 2 perfect squares and a minus sign. Do we have that? All right, so split into 2. Signs. Front. Back. And then what do I do with these? Set them equal to 0. So I'm going to subtract my 6 and then divide by 2. And these are exactly the same except it might help if I put that in the right spot. Yeah, one will be negative and one will be positive because these are exactly the same, right? With just one small sign change. So I'm going to end up with, that should be -3, and this one will be +3. So I'm crossing the x-axis at -3 and at +3. Okay, 17, I'm back to having a trinomial. So is the front a perfect square? No. Okay, so I don't have a perfect square, which means I need to look for a common factor, right? So do all of these divide by something? By 2, right? Now, if I'm just factoring, I would need to pull the 2 out front, right? And it would stay out front, and I would factor the rest of it. But since it's an equation, I actually don't have to put the 2 out front because I can do something to both sides, right? I can just divide everything by 2, which gives me 25y squared plus 60y plus 36 equals 0. But if I'm just factoring and I'm not solving for x, like if I don't have the equal sign at the end, then it would just stay out front, right? Okay, so do I have a perfect square now? And back here, and a plus sign, and 2 times the square root of the 5 up here, 5y, times the square root of 6. Does that make 60? Yes. So I have 2 of the same. All right, signs, front, and back. And if you've already checked your middle, you already have those numbers, right? Like they're literally like staring at you. All right, so I set that equal to 0. I only have to do it one time because they're both the same. So that will give me -6/5. How many answers does that count for? And it means that I am crossing, or I'm turning on the x-axis, right, at -6/5.